This example explains how to compute the lateral earth pressure based on Rankine's theory for two layers backfill. Determine the Rankine active force per unit length of the wall and the location of the resultant line of action. Retaining wall, vertical back face with vertical back face, and two types of soil. The first is sand but with phi equal to 30, and the second also is sand but with phi angle of internal friction equal to 38. The water table at depth equal to 3 meters. First we have to construct the following table and compute the active earth pressure at 3 points at the top, and at this point also, because the soil is changed, because the soil is different from the first layer, so we have to compute lateral earth pressure at this point and also at the bottom point. Here the type of the soil number 1, and depth equal to 0, sigma vertical and sigma horizontal will be equal to 0. For the second point, since this point might be belong to the first layer and might be belong to the second layer, we will have two different values of lateral earth pressure. So we will take a point above this point by, for example, plus 5 centimeter and less than for 5 centimeters. The first point belong to first layer and the second point belong to the second layer. Here 3.05, just little less than 3 meter here belong to this layer, and 3.05 positive belong to the second layer. For the point at 5 centimeter above this in this layer, the K active can be computed based on Rankine's theory. 1 minus sine 30 over 1 plus sine 30 gives 0.333 or 1 over 3. Okay, active 1 over 3. Sigma vertical here 1. Sigma vertical equal to 3 meter times the gamma soil unit weight of the soil equal to 16 gives 48. 48 is the sigma vertical. Multiply sigma vertical by K active gives the active lateral earth pressure here 1 over 3 times 48 gives 24. Draw this point here, a linear distribution of lateral earth pressure at the first layer, and the value of the lateral earth pressure equal to 24 kilonewton per meter cube meter square at this point. Then the second point 3 also at 3 meter but just little by 5 centimeter, for example, since the properties this point might be belong to this, might be belong to this soil, and we have different value of phi, different value of active coefficient, active lateral earth pressure coefficient. So at this layer K active will be 1 minus sine 38 plus 1 plus sine 38 gives 0.238. So K active for the second layer 0.256. The vertical stress also 3 meter multiplied times 16 equal to 48. 48 multiplied by K active gives the value of active lateral pressure equal to 12.3. Here at this point 12.3. The stress at this point, when we compute the lateral earth pressure considering the properties of the first layer, gives 24. When we consider the properties of the second layer, it will be 12 12.4. 12.4. At the bottom of the retaining wall, at depth equal to 7 meter, K active equal to 0.256 for the second layer, and sigma vertical at this point equal to 3 meter times 16 plus 4 meter times 19 minus 9.81 submerged effective unit weight equal to 884 kilonewton per meter squared. 84 multiplied by the K active gives 21. At this point, at the bottom of the retaining wall, the value will be 21 here, 21.7 kilonewton per meter squared. Now, to compute the active force, we have to calculate the area of the first triangle, divide all the areas to 4 regions. First is triangle, second is rectangle, third is triangle, and the fourth is triangle for the hydrostatic pressure, which is equal to 4 times 9.81 equal to 39.24 kilonewton per meter square. For the first layer, for the first region 1/2, 3 meters is the height and 24 is the stress, plus A2 for the second region, second zone. Here is a rectangle. The height of the rectangle is 4 meters, 4 multiplied by 12.3, and the third is a triangle. Triangle 1/2 times 4 the height of the triangle times the difference between 21.7 and 12.3. The stress here will be equal to 21 minus 12 plus 1/2 times 4 the height of the fourth zone, 4 meter times 39 gives 182 kilonewton per meter. This is the resultant of all the lateral earth pressure, the force that applied due to active case. What is the location of this force now? By taking the moment of the resultant, about the point at bottom equal to the moment of all the forces about the same point. Therefore, Z dash equal to the force from area 1, 36, multiplied by the distance from this point, since it acts at 1/3 of the height of this triangle, 1 meter, plus 4 meter equal to 5 meter. The force of this triangle about this point shall be multiplied by the distance from this point to this point. And then for the rectangle, also the force at the center of the rectangle area, this force has to be multiplied by this distance, 4/2. So here 49.2 multiplied by 4/2, and then the third force 18.8 times the distance here. The distance is 4/3. for the fourth zone, force has to be multiplied by this distance also, 4/3. 78.48 times 4/3. All of these moments divided by the total force, 182, gives Z dash equal to 2.236 meter. Therefore, the resultant of the all active earth pressure, the resultant force will be acted here at a distance from bottom equal to 2.236, here 2.236, and the resultant is 182.